Hi. Okay, today we're going to talk about the sum and difference formulas. This is 5.2 in your textbook. And the goal is to use the sum and difference formulas to find exact values that we could not find without the use of a calculator. So we're going to base it off the regular values we know, which is 0 degrees, 30, 45, 60, 90. And we're going to find the exact values. So the first thing we need to do is take a minute and let's copy down these sum formulas. We have the cosine of alpha plus beta equals the cosine of alpha times the cosine of beta minus sine of alpha sine of beta. Notice here that when we're dealing with cosine, we have the same trig function. Then we change the sign, different sign. So if it's plus, it's now minus. Same trig function. Okay. So let's go ahead and write the difference formula for cosine. So cosine of alpha minus beta is equal, we want to keep the same trig functions, cosine of alpha times the cosine of beta, and we want a different sign, so it's going to be positive plus the sine of alpha times the sine of beta. Okay, so there's the sum formula, there's the difference formula for cosine. Let's look at the sum formula for sine. Sine of alpha plus beta, and this one's different. And for the sine one, you use different trig functions, but the same sign in the middle. So it's the sine of alpha times the cosine of beta plus cosine of alpha sine of beta. So you just want to make sure that these angles are switched up. If you use cosine of beta here, you want to use cosine of alpha here. Okay, let's go ahead and write the difference formula for sine alpha minus beta, and that will equal, now we want to follow the same pattern using different trig functions. So the sine of alpha times the cosine of beta, same sign, so minus cosine of alpha times the sine of beta. And that's the sum and difference formulas we're going to be using. Now I put mine on a index card so that I could then have them out when I'm working a problem, or bring them back for my workspace when I'm working a problem. You do need to memorize these, okay? And we'll be adding to it later because they will be sum for tangent, but not right now. We're using sine and cosine. So there's a couple other things we need to recall. Okay, a couple other things we need to recall. And so let's recall some basic trig functions that we really need to know. Okay, so this should be something we already know. If not, you need to work on that. Practice the hand trick, and I will send out a link on the hand trick again to remember these. But if we have an angle theta, 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees, we should be at the point where you can tell me what the cosine of theta is and what the sine of theta is without the use of a calculator. So let's go ahead and put up there in case we don't have those memorized yet. We want to make sure we do get them memorized. Okay. Cosine of 0 degrees is 1. Cosine of 30, square root of 3 over 2. Cosine of 45 degrees, square root of 2 over 2. Cosine of 60 degrees, 1/2. Cosine of 90 degrees is 0. sine of 0 degrees is 0. Sine of 30 degrees is 1/2. Sine of 45 degrees, square root of 2 over 2. And sine of 60 degrees, square root of 3 over 2, and then 1. Alright, so we will be needing these. So if you don't, like I said, if you don't have these memorized yet, please try and get those memorized. Use the hand trick. I'll put a link out to that. But definitely you're going to need these available today. Alright, so what we're going to do today, we're not going to use a calculator, and we're going to find a trig value. Here's our first problem. Example 1. Very basic example. Let's find the exact value of sine of 75 degrees. Alright, so notice that sine of 75 degrees is not on our list of ones that we know. So we've got to think of a way to break down that, and we're going to find a way to use one of these where we're adding or subtracting to get that 75 degrees. Okay, so let's think about it. Alright, so sine of 75 degrees is the same as the sine of 45 degrees plus 30 degrees, both of which is on our list of things we know. So the big temptation is to distribute the sign, but that is not what you can do. You cannot not distribute that sign. You have to use your identity. So we're going to use sine of alpha plus beta equals the sine of alpha times the cosine of beta plus cosine of alpha times sine of beta. Okay. Notice I put that on my side area because when I work, I want to work downward so that every line equals the prior line. So sine of 45 is going to be our alpha. So we're going to let alpha equal 45 degrees and beta equal 30 degrees. So now we plug in and use our formula. Okay. So we have sine of 45 degrees times cosine of 30 degrees plus cosine of 45 degrees times sine of 30 degrees. And these lines are equivalent. So this prior line is equal, this line here is equal to the prior line. And now we're going to use substitution. So if you don't recall, make sure you have your handy dandy chart with you because you're going to need it. Okay? So sine of 45 degrees, square root of 2 over 2. We want to multiply that to the cosine of 30 degrees, square root of 3 over 2, plus cosine of 45 degrees, square root of 2 over 2, and the sine of 30 degrees, 1/2. Okay, and we're multiplying this. So when you multiply fractions, you multiply the numerators, then the denominators. So square root of 2 times the square root of 3 is the square root of 6. 2 times 2 is 4. Square root of 2 times 1 is the square root of 2. 2 times 2 is 4. Now, because we have the same denominator, we can go ahead and put it under one denominator. So our final answer is the square root of 2, square root of 6 plus the square root of 2 over 4. Okay? So let's test that and see if we have that correct. We can use the calculator to check our answer, but you should be able to do this without the use of a calculator to get your answer, and then you can go ahead and check. First, make sure you're in degree mode. So go ahead and change that if you're not. All right. And so let's find the decimal approximation of the square root of 6 plus square root of 2. Find that, and then we want to divide by 4. So our decimal approximation is 0.9659, and so on and so forth. I would say you can assume it to be about, take it out to about 4 decimal places. So this is our exact answer. Is right here, and this is our approximate answer. Now they wanted an exact answer, but it's good to get an approximate answer also to kind of give us a feel for what we're doing here and to check our work. So we found out what this is approximately. Now let's see if that's correct if we just straightforward do the problem, sine of 75 degrees. Well, lo and behold, it's one and the same. It's hard to see it, got a lot of glare going on, but one and the same. So we're good. Now we have a way to check our answer. All right. So let's go ahead and give you one to try. I want you to try this one. Find the exact value of cosine of 105 degrees. So I want you to do this without the use of the calculator. So find the exact, so pause here, work it out, and then come back and let's see how we did. So hopefully we're in agreement that cosine of 105 degrees is the square root of 2 minus square root of 6 over 4. The key thing is to know how to break down your 105 degrees in some combination of the angles we know. Okay, so sometimes there's more than one way to do it. You could have said cosine of 60 plus 45 rather than 45 plus 60. But you do have to break it down. Then make sure a good habit is to identify the rule that you're using. So we are using the idea that cosine of alpha plus beta equals this right here. Plug in what you know, using the rules, the formula specifically, off of your chart. Pull the values, simplify, be careful when you're multiplying the square roots. Okay, you can multiply the square roots, no problem, but you cannot add and subtract square roots that have different values underneath. So the exact answer is the square root of 2 minus the square root of 6 over 4, and it's an approximate answer. If it asks you for an exact answer,